So now that we got our boxes falling around, let's play around with a few values just to kind of reinforce what some of these things do. We'll switch back to our add a random crate function and let's fool around with some of these values. What if I set friction to 0? As you might expect, you're going to get blocks that are very slippery. You can watch them all kind of slide around on each other. You'll notice we seem to end up with sort of a more ordered look to our boxes than before because I think the lack of friction gives them the ability to kind of line themselves up better than they could before. That's kind of fun. You will notice, however, that it seems to take our world a little longer to go to sleep than it did before because without friction, all of these boxes still get to move around a whole lot. If we undo that, and let's set our restitution, remember that's our bounciness, to something high, like 0.85. This time, as you might expect, we get to see our boxes bounce around a whole lot more. Suddenly they're not so much crates of wood, but they're crates of super balls. It's kind of fun to watch. But now let's, what happens if we change the value to something greater than 1? What if our restitution is 1.3? And we get super bouncy crates. What's actually going to happen is, as they hit the ground, their kinetic energy is going to increase, and none of them are actually going to stay in the world. They're all just going to keep bouncing and colliding off of each other, gaining more and more energy until they completely fly out of my world. So this actually probably isn't a good idea, which leads to an important life lesson. Thermodynamics, it's not just a good idea, it's the law. So, sorry, that was really nerdy. We'll switch back to our code and move this back to 3. What happens if we change our density to something really dense? Something like 3.7. This is probably the density of, say, lead. Now you may notice a slightly weightier feel to these boxes, although it's a little hard to tell if that's because we've changed the density or because we set our restitution back to a sane level. I think more often you'll notice different values in density when you're colliding objects of different densities. Because we've made our crates all have the same high density, you're not going to really notice a change here. Probably if we had half of our boxes have a heavy density and half have a light density, you would see more of a change. Go back to our code, change this. What about if we, let's go up to our world.step function that we call every frame. What if we change this iterations number from 10, which means we kind of pass through all of our objects 10 times to make sure they've settled in the right place, and change it to 1. What you're going to end up with is a lot more kind of intersection errors. You can kind of see it here. It might be hard to see in your version of the movie. I'll probably zoom in and show you some more specifics, but you can kind of see these objects are all overlapping, and that's because the physics engine really isn't able to, within one pass, put all these objects in the place they're supposed to be. We also seem to have some sort of odd shifting and jumping in our boxes, and that's also due to our very, very low restitution number. So that's sort of a side effect of setting it too low. On the flip side, if we set it very high, if we set it to something like 100, well, this actually doesn't look too much different than if we had it at 10. I'm sure my code is running at a lower frame rate than before, although I don't have anything set up to measure it. But you'll actually notice that in spite of the fact that we're probably doing 10 times more calculations per frame, where the boxes don't seem to look a whole lot different. So that's why we leave it at 10. Hey, by the way, what happens if I change this world.step? Right now I'm telling our Box2D world to calculate 1/30th of a second passing every frame. If I change this to something like 1/120th of a frame passing, even though I'm still running at 30 frames a second, we're basically going to get a world that runs in slow motion. Sorry, that weird popping you're seeing at the beginning is the fact that I'm still introducing a box every 5 frames, even though it's now taking 4 times as long for the boxes to kind of get out of the way and fall into the world. So we basically got something that's kind of moving in slow motion, and you can sort of see that happening. This might be useful if you wanted to actually create some slow motion effects in some of your games later on. I'm going to set this back to 30. Let's fool around with this ratio number. Suppose that we said, you know what, I don't really care to make this 40 pixels per meter. I hate doing all this multiplication and division. Let's just set it to 1. It'll save me a bunch of programming errors. And so the first thing you might think is, wow, did we forget to turn off slow motion? Because things seem to still be falling very, very slowly. And no, we're actually running at normal speed. What you're seeing is we've basically told the Box2D engine, hey, it's now basically half a kilometer from the top of our Flash movie to the bottom. And so it's just taking these huge, huge objects forever to actually make it down there. So that's why it kind of looks like it's running in slow motion. It's not. Just imagine these are massive objects and you have the camera pulled back very, very far. They actually seem to handle most of the collision errors pretty well, given that these boxes are probably larger than the engine was planning on running. But just for the fact that things look kind of weird and slow motion-ish, I would not recommend keeping your pixel to meters ratio at 1. We'll turn this back to 40. Let's do one other thing. Let's set our gravity. There we go. We will set our gravity to something besides going straight down. For instance, maybe I want it to go to the left and down a little bit, so it's at almost a 45-degree angle. Now when I run it, you can kind of see that all my boxes are sort of falling at an angle. If you tilt your head to the right about 40 degrees or so, it'll look like things are behaving normally. Looking at it straight on seems a little strange. But again, this technique could be useful if, say, you wanted to create one of those games where you've got the marble going through the little labyrinth. Essentially, when you tilt that wooden labyrinth, you're kind of changing the gravity. So this might be a good way to simulate that kind of game. And that's at least some of the experimentation we can do. Before we completely wrap up this whole chapter, I'm going to answer a few questions that you may have still in the backs of your minds.